are just adding. So complex zeros are the ones that have eyes. So remember, every zero is a complex zero. The real ones don't have eyes. So we are going to do, just add to what we did yesterday. So fundamental theorem of algebra, we already talked about a few days ago, but this one includes complex zeros. So the polynomial's degree, so if it's a fifth degree, it's going to have 5 zeros. When we wrote this before, we said at most 5 real zeros. Now we are saying it has exactly 5 zeros if you count the complex zeros. So between real and imaginary and multiplicities, you're going to have exactly the amount of zeros as you have your degree. Okay? And you have that many factors. If I were to do a linear factorization and I write them all out, you have that many factors. So if it's a fifth degree, you'd have 5 parentheses. Or you might have 1 parenthesis with a cube, and then 2 more, those multiplicity ones. Okay, but you would have a total of 5. So that's kind of the same thing we talked about a few days ago. It's just including complex. All right? Now, complex numbers are in the form a plus bi. I am going to take a minute and do this question, because we had some hiccups. Find the zeros. Okay? So I can't factor that. There are no factors of 8 that subtract to 3. So it can't be factored, which tells me my zeros are either irrational or imaginary. So we are going to say opposite of b plus or minus square root of. So if I can't factor it, I still can solve it doing the quadratic formula. Okay. This is 9, and this is 32. 9 plus 32 is 41. So that's the reason it can't be factored, because it has a quadratic. It's a square root of 41, which is irrational. Okay? You would leave it like that. That's 2 answers. Okay? We're going to do another one. By the way, these answers are called conjugates. I'm going to write them separate. When you get that plus minus thing, that's a conjugate answer. Okay? When they're stuck in radicals like that. Let's do another one. Logan.
How do you spell conjugate?
C-O-N-J-U-G-A-T-E. It's going to be on another slide. Conjugates. Okay? All right. So let's try one more. You guys try this one. So again, if I'm looking at this, there are no factors of 7 that add to -2. So I can tell right off the bat this cannot be factored. So I have to do the quadratic formula. And again, guys, some of you still real weak with that. Practice, practice, practice. Find all the zeros. Now this is going to be kind of one of the big daddy questions. Okay? I'm not giving you anything. I gave you that. So if, like Sebastian, you could just factor that puppy right now, you'd be good to go.
All right. You got 5 x's.
So we know we're going to have an x. Yes, you would.
Parentheses x minus blank. Parentheses x minus blank. Parentheses. Like 5 or so times. So on the big one, you put a plus. So minus.
Okay.
So you have a whole lot of.
It's going to be pretty difficult, isn't it going to be, Sebastian?
Just give me a minute. There's a 3, a 5, 5, 6, 8, and 1. So So what's the biggest factor between those? You might be asking. It's 1.
Uh-huh.
Yeah.
Okay, so let's do it the way I'm going to teach you how to do it so that we don't like completely blow our brain, okay? So if you're not given, yesterday I gave you a worksheet and I gave you that little starting point. What if you don't have a starting point? What's the little rational root theorem we could use to find a starting point all by ourselves? Take the factors of the leading coefficient and the factors of the constant. So our Q is a 1, our P is an 8. So our factors are 1 here, 1, 2, 4, and 8. So our possible rational factors are 1 over 1, which is a 1, 2 over 1, 4 over 1, and 8 over 1, plus or minus for all of those. So we have 8 numbers to test. And we just get out a handy dandy calculator and we test them. So if I put 1 into this function, what am I looking for? A 0, right? If it gives me a 0, I know that it's a root. So if I put a 1 in there, oh, I get 0. Spectacular. If I put negative 1 in, nope. If I put 2 in, do I get a factor? I don't think so. If I put negative 2 in, do I get a factor? Yep. If I put 4 in, does it work? Yep. So as soon as you get, I got 3. Do I have to do all of them? No, there are no other real roots. I'll tell you that now. I have a 5th degree. I have to bring it down to a what to be able to work with it? A 2 degree, right? So if I have a 5th degree, I need 3 rational roots to bring it down to a quadratic that it can factor. Again, unless we're Sebastian. The rest of us, we have to bring it down to a quadratic, okay? So we're going to use these 3 zeros in synthetic division to drop this down to a quadratic. Right? And we can do this. I know you can. We put a 1 here. 1. Does it matter the order that I put these zeros? Nope. And I'm just going to kind of buzz through this because I think after the worksheet yesterday, you guys are pretty good at this. And if I do not get a 0 here, I have screwed up.
Go get Peters.
Here we go. So now we're going to go and use the next 0, negative 2. We're still using this answer coefficients, right? Don't go back up to the original. Dropping this down. Oh, I got to use my blue. Can't do it without blue. Again, I'm looking for a 0 here. Got it. And our last one's a 4. Now each time I do synthetic division, my degree is dropping. That's a 4, that's a 0, that's a 0, that's a 1. So I had a 5th degree. This is a 4th degree. This is a 3rd degree. This is a quadratic. So I have x squared plus 1. I can't factor that. So I have 2 choices. I can do the quadratic formula. Or there's no x here. If there's no b term, okay, there's no regular b, you can just set that equal to 0. And I would get x squared equals negative 1. What is the square root of negative 1? Plus or minus I. And then you're done. You get the same answer with the quadratic formula with a lot more steps. Okay? So if there's no b, there's not necessary to do the quadratic formula. All right? So they wanted our zeros. Our zeros are 1, negative 2, 4, I, and negative I. We have 1, 2, 3, 4, 5 zeros. We have a 5th degree. That's how many zeros we should have. And then if they want the linear factorization, you just write those in factors. and we have 5 factors in our linear factorization. So, and I'm making fun of Sebastian, but I don't need to. This is why it would be difficult to do that. You could take a cubic or something and figure it out, but with the imaginaries, that would be almost impossible. It would be difficult. Unless you're Sebastian. Then all bets are off. Okay? So you understand how you can do that? If you aren't given a starting spot, you could find one yourself. Right? Okay. Most of the time, we're going to give you a starting point. Yeah, we're not going to do that one. Here we go. This is the Big Daddy. I would take notes on how to do this. This is the Big Daddy question on the test. When you see the steps and you go, holy Jeezies, this is all one question, we're like, yeah, that's it. Okay? So they're telling you we have a 4th degree. I'm given 1 root, 5i. Oh, but wait, if I'm given 5i, I automatically know.
Should I say the page for this?
Yes. I would start a new page. If I'm given 5i as a 0, I would automatically have negative 5i as a 0. So I have actually 2 zeros. Now let's think about what we did yesterday. I gave you a 0. 3 is a 0. And what did you do with that 0? Synthetic division. Got it down to a quadratic and then you factored, yes? I can't do synthetic division with an I. So what you have to do, write these as factors. I have 2 of them. We're going to FOIL this together. And again, x squared, the O and the I cancel. Minus 25i squared gives me x squared plus 25. Well, tartar sauce, I can't do synthetic division with an x squared, but I still need to do division. So what other division do I have left? The dreaded long division. There's a reason why we learned long division, and this is it for the Big Daddy question. All right, so I'm missing my x term, so I'm going to put a 0 up here so things line up pretty for me. Okay, so when you can't do synthetic division, and you will not be able to if you have imaginary zeros given to you, you've got to write the conjugate, write factors, FOIL it together, and then do long division. So there's lots of points here, as you can see. So what do I multiply x squared by to get 2x to the 4th? 2x squared. I multiply this to all 3 terms out front, so 2x squared times 2x squared is 2x to the 4th. 2x squared times 0x is 0x cubed. 2x squared times 25 is 50x squared. Then what do? I go by and I switch all the signs because we're technically subtracting. And then you put your lines together. So I would have negative 7x cubed minus 15x squared, and then I'm going to drop down my next line, the next number. And you start again. X squared times what gives me negative 7x cubed? Negative 7x. And you multiply to all 3 things out front. You draw your line, and you change all your signs. And then you put your lines together. We got one more. That's my last number up top. Negative 15. Everyone with me? So we get negative 15x squared plus 0. What's the remainder got to be, guys? It's got to be 0. You are dividing by a known factor. If your remainder is not 0, you did something wrong. Okay? So, our answer is our quotient here, my quadratic. And I still need to factor that. Um, 15, 5, and 2. 5 and 3. So I can factor that quadratic, and then I set those guys equal to 0 to get my other 2 zeros. And I already have plus or minus 5i. So understand how many steps it takes to get one of those done. You'll have 4 of those on your test. I lied. You'll only have 1. Thanks.
Now, you have x squared plus 25,
Mm-hmm.
which gives you, can you not set that to 0?
Well, we don't need to set it to 0 because that's what we came from. Those are our zeros. We already had x equals 5i and x equals negative 5i as zeros.
So if you set x squared plus 25.
No, because when you move the 25 over, you get a negative 25. And then when you take square roots, okay? All right? Does that make sense? So we have 1, 2, 3, 4 zeros. Big question. All right, now we are going to work on just some like 4 questions. One of them we already did, so you have 3 questions for homework, and then we're going to do a worksheet tomorrow.
We're going to have